Hi everyone, welcome back to my channel. In the last video, we explored how gradient boosting regressor was working, which was focusing on predicting a continuous value. In today's video, we'll see how it's working for classification, which is try to predict categorical. For instance, we have here binary classification 0, 1. And from the last video, let me just recap how it's working. So it's working as follows. So you have a data set. It will try to create a weak classifier. Usually, it's a decision tree. Initial predictions. It will be, for instance, taking the mean of the class label. Let's say of the regression values, and but here it's different in classification. And calculates the residual. Train the next classifier. Update the predictions, and if still needed to improve the accuracy, it will do again, and etc. So this will be repeated, let's say, several times. In the classification, we try to predict the categorical, and we'd like to minimize the log loss, which is called cross entropy. So in the regression, we use mean square error. So let's say this, we have this data set. The first step we have to do is to make a constant prediction. So in the classification, we will try to get the total number of ions and total number of ones and total number of zeros. And if you see here, we have two zeros and two ones. It will be applying this formula, it will be 0. Now we will try to make the sigmoid function, which is this one here. It will be minus f0, which is 0 here. It will be minus 5. Now we will do the the initial prediction. It will be 0.5 for all uh, of these samples. Let's see, we have four samples here. Now we will try to calculate the gradient, let's say, pseudo residual. It will be this one minus the b0. It will be this minus the value that we got from this formula here. And this will be minus zero point 0.5, minus zero point 0.5, plus zero point 0.5, and plus zero point 0.5. Now we will try to use the next classifier, which is, let's suppose we use a decision tree to predict this class label here, to predict this residual, not to predict the target. So this is the principle how gradient boosting is working. Now assume that we have, after constructing the decision tree, we will have this, for instance, minus point 5 if x is less than 2.5. For instance, this is x. If it's less than 2.5, it will be minus uh, zero point 0.5, and etc. Now we need to calculate the updating the loss, the loss. Let's see the logit value. It will be this, the f0, which is calculated from from the above, and it will be this one here, and 0 minus, this is what was 0, 0 minus, and the learning, let's say learning rate is zero point 0.5, and multiply by the first predictions, and it will be like this here, converting this to the probability, and this will be the 3.4 and point 0.6, and etc. Now we will repeat this several times. For the classification, we will see any value is greater than zero point 0.5, which will be considered as 1. And you can see, if this is only for example, you can see this is 1 1 0 0. I mean, after the threshold, this will be less than zero point 0.5, it will be 0. Less than zero point 0.5, it will be 0. Greater than zero point 0.5, it will be 1 and 1. And if you see the class label, it will be somehow 0 0 1 1. So because it's only a simple example, it was covered so forth quickly. And what's the difference between the regression and classification? We already know. And in classification, it's try to minimize the cross entropy. And instead of calculating the residual, we're calculating the pseudo residual, which is log loss. And we update the predictions and using the sigmoid function, and update the, I mean, repeat the process several times until we get, let's say, the best performance. As usual, I will try to show you how it's working with Python code with only a simple example that we have used in this document. So as you can see, 11434, and this is the main important one, is to focus on this. How did we import the boosting classifier? And here as a parameter, we need three decision trees. Let's see, or let's see, weak trainers. And here the learning rate and max depth is one. For instance, each decision tree is used, it has to be only one node. So for instance, X, either yes or no. And we have the prediction. And so I think this is enough for today. And next video, I will try to integrate this in the our classification project, so we can make, let's say, a complicated or comprehensive classification project that use all of these classification algorithms. If you like this, please subscribe into my channel and like this video. And if you have any question, of course, drop a comment below. I will answer it. Thanks for watching and see you next time.